Okay, so this question, practical revision question on combinations of resistors in series and parallel. So this first question, I've got to find the missing value, so I need to find V1 and I need to find V2, which is voltage across this little branch of the circuit, and I need to find R4, which is this value in this little combination, and I1, which is the current through R1 in that little branch. So, well, I know these resistors, so I can work out what the total resistance of that particular part of the circuit is. And if I know the current here coming into this particular little combination of resistors is 3 amps, then I could find V1. So I can use Ohm's law to do that. If it's 3 amps flowing into that little branch of the circuit, then it must also be 3 amps flowing into this little branch of the circuit. So I know the current going into there. I also know that this is a 14 ohm resistor here. So I could actually find the voltage across this little resistor, R6. So if I know the voltage across R6, and I've just found out what the voltage is across this branch in the circuit here, V1, I could then work out what the voltage is across what's remaining using Kirchhoff's voltage law. So then I can find V2. Once I know V2, I know the current is 3 amps through this little combination. So I could work out what the total resistance is in this little part of the circuit here. Knowing the total resistance, I could then use the resistors in parallel formula to find R4. So that's the sort of way I'd go about doing it. Once I know I1, once I know what this voltage is for V1, which we found earlier, then I could actually easily find out what the current through there is, again using Ohm's law. So that's the sort of idea. See if you can have a go yourself, but the solution will follow below. So the first thing I'm going to do below is to try and find out what V1 is by finding the total resistance of this little combination of resistors here. So here's a solution for to find V1, or part of the solution to find V1. The first thing to do is find out the total resistance. So 1 over 30 plus 1 over 15 plus 1 over 10. Common denominator at 30, so I can turn them all into something over 30. And then I can find out what RT is. RT turns out to be 5 ohms. Now I know that the total resistance is 5 ohms, I can easily, using Ohm's law, find V1 and actually I1, which is the current through one of the resistors in this little 3 combination. So see if you can do that, find V1 and I1. The solution below will follow. So here is the solution for V1. The current, which is 3 amps multiplied by the total resistance RT, gives us 15 volts. Once I know the voltage V1 across that 3 resistor combination, I can find the current through I1. The current through the 10 ohm resistor is just V over 10, and its 15 over 10 is 1.5 amps. So now, having done that, I'll probably try and find now the voltage across R6, and then once I know that, I can find the remaining missing values, which is the voltage across the 2 resistor combination and the value of that final resistance. So see if you can carry on and finish the problem. Solutions appear below. Okay, the voltage across the R6 is going to be your current through R6, which is 3 amps, multiplied by the value of that resistance, which is 14 ohms. So 3 times 14 gives me 42 volts. I know that the total supply voltage VT is 75 volts. So 75 volts minus the voltage across the 3 parallel resistors combination that we found earlier, and the voltage across R6 that we just found, 15 plus 42, will give us the remaining voltage across the 2 resistor combination. So we have 18 volts. So I now know that V2 is 18 volts, so I can go ahead and work out what the total resistance of that final combination is, and then work out what the missing resistor is. See if you can finish the problem. Solution appears below. Okay, so to find R4, there's kind of three ways we could do this actually, and I've outlined the solutions here. You could pause at any point and see if you can carry on with the solution. So the first thing I would do would find RT. RT equals V2 over I, which is 6 ohms, because I know that V2 is 18 volts, as we've discovered, and the total current is 3 amps, so that means 6 ohms is the total resistance. Now, I could use this formula. The total resistance is product over sum, and then substitute in. The total resistance is 6 product R4 times the resistor I know, which is 9 ohms, R5, so 9 times R4 divided by 9 plus R4. Then we've got a bit of algebra. Multiply both sides by this expression underneath, equals 9R4. Expanding out the bracket, 54 plus 6R4 equals 9R4. Collecting like terms, taking the 6R4 over the other side, we've got 3R4 equals 54. Dividing by 3, we've got R4 equals 18 ohms. So that's one way to do it. A little bit of algebra involved with it. Another way to do it would be to use this formula. It's 1 over the total resistance is 1 over R4 plus 1 over R5, which is 2 resistors in parallel. Substituting in what we know, 6 ohms and 9 ohms. So 1 over R4 is going to equal 1 over 6 minus 1 over 9. Common denominator is 18. So 3 over 18 minus 2 over 18 is 1 over 18, and that gives us 1 over R4, so therefore R4 must be 1 over that, which is 18. So again, 18 ohms. Or another way, and I'll leave you to do this, would be to actually use your knowledge of the circuit to say, find the current I5, then I4, then R4. So in other words, if we look back at the original circuit, if I know the total resistance at the total current is 3 amps through this combination here, I now know V2, so I could actually find the current through this R5 here quite easily using Ohm's law. So if I found the current through this bit and I know the total current, I can find the current through that. With straightforward subtraction, once I know the current, and again I know the voltage, I could work out the resistance. So we could do it another way and see if you can get 18 ohms that way. Okay, so that's that problem finished.